All right, so you got all these, right? And then I put at the end the Wednesday problem, so you have access to that. But I'm just going to go ahead and just point out my thought process as to what was it that made me choose the method I did. Now, that being said, some of the issues you might be having with these, and it's true, is some lingering issues with dealing with fractions, fractional expressions. There may be some lingering issues. And so now we're throwing trig functions here. So it's kind of like double tough good, right? So anyway, generally changing everything to sine and cosine tends to be a good idea, but of course it does depend. In this case, it's certainly that was a good first step. And then sometimes maybe that might not have been a good first step, and then you just got to go back and try something else. So I wouldn't multiply based on a conjugate right now. To me, that would make this more challenging. So let's keep it simple first. Change everything to sine and cosine. Then the next step is to simplify this complex fraction by getting rid of all denominators. And since in the top you have cosine and sine as well as the bottom, you're going to need to multiply both cosine and sine. And I'm just abbreviating here to remove some of the complexity. Once it got to a point where I felt I could go to the trig functions again, that's what I did. And notice when this happens, you divide off a cosine, you get sine times sine. You divide off a sine, you get cosine times cosine. Same thing on top. So on the bottom, you get the trig identity, sine squared plus cosine squared equals 1. And then here, the same kind of thing. It didn't seem to be any different than this first problem. And so it did the same thing. We'll change the cosine sine, multiply top and bottom by cosine sine. And then here you had an additional step, which means recognizing a trig identity from the Pythagorean identity. Because this is really 1 minus cosine squared. And sometimes that takes a little while to get used to. You might do everything perfect and then you get stuck because you might not recognize the last step is actually a Pythagorean identity. And so that's what happened here. And then we got everything we needed. Okay, now this one, it looked like it'd be better to change everything to sine and cosine. And so what I did on the left was did that. And then, oh, wait, on the top, there's a common denominator. So let's do on the bottom, get a common denominator. All right. So again, I'm not always sure if the first step is a good step, but certainly doing something that makes good sense is a good idea. So getting a common denominator. And I got to here. Okay, so dividing by a fraction, multiply the reciprocal. Okay, so at this point, sometimes we get a little confused because we're not seeing something that can be done. So when you get to this, well, let's see. We got a 1 plus sign. If we're trying to make this become tangent secant, we need to somehow get rid of that 1 plus sign, right? Okay, well, how can we do that? That means we're going to need something on the bottom that will divide off the 1 plus sign. Okay, well, what can we do on the bottom? Oh, it looks like we can factor out a cosine here. And as soon as we do that, that does the trick. And then what's left, we can rewrite. So sine over cosine, which is tangent, and 1 over cosine, which is secant. Okay, and then here it seemed to still be a good idea to change everything to sine and cosine. So now, since these are both tangent squares, the denominators are the same, so multiplying by cosine squared, and that enabled us to get this trig identity, cosine squared plus sine squared, which is 1. And then once we're at this point, if we're trying to get this to be 2 cosine squared, we need to make that sine squared cosine squared, which means replacing the sine squared with 1 minus cosine squared, and that gives us our trig identity. And that's a plus 1 there in case you didn't catch that. I squeezed that in because that's what was over here. So then that minus gives us the minus 1 plus 1, then we're done. 69, again, it didn't seem to be a bad idea to make sine and cosine on the left since that's what's on the right. And then this one was quick. That was really the only thing you need to do. Next step, multiply top and bottom to get rid of the denominators, and that enabled us to get to here. All right, now this one, I went ahead and did the change to sine and cosine on both sides. Okay, so first I did that on the left side. So let's get a common denominator because that's a good idea. That gets us to here. And I notice on top, that's a 1 minus cosine squared, which is a Pythagorean identity. Okay, so I went ahead to the right side. And as long as you're doing something on the right independently on the left, there's nothing wrong with this. So changing the sine and cosine, that enabled me to get here. And now I can see, okay, well, wait, next step would be to make this sine squared. So that verifies the identity. Now, I'm okay with working on one side independent of the other so that you can produce the same quantity on left and right. But if you have to work only on one side, you can do this method, and then on the left side, just go to the right side and write it backwards. So then this would be the next step on the left side, and then that would be the next step on the left side. All right. So I'm not really picky about that because there's too many other more important things. All right, now this was the one where it seemed a bit much. But what do you do first? Well, the complicated side is on the left. Certainly getting a common denominator is a good idea. Okay, so let's just do that. So multiply each fraction by the other denominator. Now, as I'm doing that, notice that you're really multiplying conjugates. And that's good because 1 minus sine times 1 plus sine, that'll get you a 1 minus sine squared. And then the numerators on top canceled out the sines. And then here is the Pythagorean identity that equals cosine squared. And that did the trick just by getting a common denominator and then simplifying everything and using a Pythagorean identity. Okay, and this one was a little tricky too, because you had a cube here. So we're trying to get cosine cubed on the left side. All right, so what do? Well, changing the secant to 1 over cosine. That way everything now is in sine and cosine. Okay, well, what's the next step after that? Okay, really the only thing that would be of benefit is by multiplying by a conjugate based on the denominator. Okay, so let's go ahead and do that, see what happens. Now I went ahead and rewrote this as 1 over c times the new fraction we created when we multiplied 1 plus sine on top and bottom. And even if you think about it, notice when we multiply 1 plus sine on top and bottom, that's what we want on the top if you look at the right side. So that's a good thing. All right, so then we just need to figure out how to get this to be cosine cubed. Well, we already got the cosine from the original problem. In the denominator, we got the 1 minus sine squared, but we got from doing the conjugate. That's cosine squared. Oh, there it is. And now we get the identity. Now, 77 was the only one where I didn't see it to be a good idea to make all these sine and cosine. To me, that would have made this more complicated. So I didn't want to do that first. All right, maybe that might be the way to go, but that appeared to make this a lot more complicated, so I avoided that first. All right, well, let's just go ahead and square this out in the numerator and see what happens. Okay, so multiplying, and again, be careful when you do this. It's not distribute the exponent. This is FOIL. You're multiplying two binomials. All right, and then when we do that, we wind up with the tangent squared plus 1, which is secant squared. All right, so we can combine that with this secant squared. And so this is now our numerator. Now, I didn't do the distributive property on the bottom. I left it like that at first. Okay. And then I'm thinking, okay, well, let me see. If we're going to try to get tangent, then we probably don't want this secant minus tan there. So I'm thinking, what could I do to the top to get a secant minus tan. Well, what can we do? Well, it looks like we can factor out a 2 secant. We can do that. And that enables us to cancel out the secant minus tan, which removes all the complexity. And then it's just a matter of simplifying what we have left. Now I'm turning them into sine and cosine. And then I'm multiplying top and bottom to make the bottom fraction go away. And that enabled us to construct what we wanted to get to tangent of the angle, which is in this case the variable v.